Hey, hello everyone. This is Gaurav Tirupati here. Welcome to this series on data architectures. So far, we had discussed about data warehouses, data lakes. We also discussed about the combined approach where we used to create a data warehouse and a data lake. And today, we are going to discuss the Lakehouse architecture, which is now become very popular right these days. Most of the organizations have started adopting Lakehouse as an architectural pattern. We are going to see what are the basic features of a lakehouse architecture, what are the advantages of using it, what benefits do you get. There are a few components which are part of lakehouse, a few concepts which maybe we'll take it up in some of the subsequent lectures, like the open table formats and all. We'll do a deep dive later. Today's lecture is more about a high level understanding of lakehouse and what it really means. So let's get started. So if you remember the last lecture, we mentioned that, right? We will have a architecture where we have a data lake plus data warehouse, right? This type of an architecture to overcome the limitations of standalone systems like data lake and warehouse. And this combined architecture would give you the benefits of both data lake plus warehouse. But then it had some issues like you continuously have to sync the data, metadata. There were manual efforts required to do all these things. Plus, these two are very different systems. The metadata of data lake would be different as compared to the warehouse, whereas data lake basically it is just like you keep on dumping the data. You don't really care about the schema. So fundamentally, these two are different storage systems. So this two-tier system had does cause a lot of issues. So that is where a new architectural pattern has been introduced. So somewhere around 2020 there was a paper by Databricks which talked about this new architectural pattern, and it basically mentioned, right, important things like there should be a single storage tier. Let's say there should be a single storage tier from which all the workloads can be supported, be it BI or AI, right? It should support all type of workloads, but at the same time it should be capable of giving you the performance of a like a data warehouse, right? If you remember, when we spoke about data lake, if you try to do something like a BI kind of a workload here, there is going to a performance issue, right? Because it is not like a data warehouse which is meant for BI kind of systems. So, Lakehouse and architecture, right, was introduced to tackle these things where you could still have a single storage tier, you can, but still get a performance like a warehouse. Now, this single storage tier, right, in a Lakehouse is a data lake itself. Is a data lake as in it uses the cloud object storage. It is not. It does not use the storage of a warehouse. Okay, let's start by discussing this. Okay, the first point I would say it's a single storage tier. So when we are talking about lakehouse, we talk about first is the storage part, right? Now, what is the storage in a lakehouse? So the storage is nothing but a cloud object storage. Okay, let's say cloud object storage, similar to what we did in data lake, right? If you remember, in data lake we had this cloud object storages. Now you get all the benefits of that. It is scalable, it is much cheaper, it is open as compared to warehouses, right? But then with data lake, right, there was an issue that BI performance was not so great, okay, because it is using a cloud object storage, it's not a proprietary storage. So lakehouse and an architecture, right, when this pattern has been defined, it is such that, okay, you'll be using a single storage layer like a cloud object storage, but at the same time you will get better performance. Okay, you should get, okay, better performance. So these are the features of a lakehouse. When you're building a system which is based on this lakehouse architecture, it should use a object storage, but still you should get a good performance. Okay, these are the features, and then eventually you'll see like how it is implemented, what are the technologies that help to implement a lakehouse, and then how do you get all these features. Okay, so first is you have a single storage tier, and that is a data lake. Okay, now on this data lake you would still get the features like a warehouse. Okay, now what are the features of a warehouse? You'll get a good BI performance. You should be able to get a better governance, right? Manage metadata, right? There would be a metadata, it would be able to manage it. You will get features like asset asset properties, right? Now any warehousing systems, right, the traditional ones or even the modern ones, right, these support your ACID feature. These are ACID compliant. Now, what is ACID compliant, right? If you want to understand it, it is atomicity, consistency, isolation, and durability. Okay, what does ACID mean? Atomicity is, let's say you are performing any transaction. Okay, um, let's say you want to update something. Okay, update a record. Now it and this particular query is going to update, let's say, 100 records. So it in atomicity, right, it is going to update all the 100 records, or it is going to fail. It won't be such that it will do the things halfway. It won't happen that only 50 records are updated and 50 are not. Okay, so it is basically either everything or nothing. Okay, that is what it really means. Durability is, I'll come to the other ones. Durability is, right, whatever changes you made are going to persist in the system. Okay, these will be there in the system always. So if you have done this update, okay, it will be there in the system even on failures and all. Anything happens, you will always be able to see that. Okay. um, Isolation is when two transactions are going to are trying to do the same thing at the same time. Okay, let's say there are two concurrent update which are trying to update the same record. Okay, so it should be able, okay, to handle that. And how generally it does as warehouses or even the databases, right? What happens here is, in isolation is, to concurrent transaction, it handles is as if they are coming one after the other. Okay, it treats it that way. So that first transaction is done, then the second will happen. But it should not have it won't happen that both of them are trying to update at the same time, and then database goes into some inconsistent state. Okay, so for concurrent transaction there is a mechanism, right, to handle this concurrency. Okay, so it works in an isolated way, and it will handle concurrent one. The second is the consistency part. The database is always consistent. It won't be after any transaction. The database won't get into an inconsistent state, so that you are not able to access any table. Okay, you are not able to access any table or anything. Such things won't happen. Okay, there would be constraints, a proper primary key constraint, or the whatever constraints you are going to add. So those things would be there. So it basically applies this ACID compliance. So Lakehouse systems are ACID compliant, okay, whereas data lakes are not. Okay, they are not meant to be ACID. But if you are building a lake house, so this is a feature. So see, lake house is a combination, okay, of a data lake and warehouse. So it will have good features from both the systems. So whatever are the good features of a warehouse, like ACID compliance, it will be there. Governance, access control, okay, BI performance, it would be there. All the good things from the data lake, like using an object storage for scalability, okay, cheaper open systems, it would be there, right? So we spoke about ACID, we spoke about single storage tier. Okay, most important thing is it will support all the data types. Okay, see here, data warehouses traditionally supported only the structured one, not the unstructured, and data lake supported all of them. So Lakehouse would support all the data types, and because of this, you could do all the workloads from BI to AI. Okay, so BI workloads are also possible with really good performance. Okay, like a warehouse like performance. Whether it is as good as the warehouse, it all depends on the configurations, machines, a lot of other things. But yeah, you can still get performance which is much better than just running it on a data lake. Okay, it also support AI ML use cases because you are getting the unstructured data, right? All those things are going to happen. So it is nothing but a data lake with warehouse like a like features. I'll also show you the architecture in next couple of slides so that these things are clear. Now, how does it what where does the magic happen? How does a data lake start behaving like a warehouse? There is something called as the open table format. Okay, I will talk about it in the next slide. This is the technology, okay, which helps you to do this. Okay, this is the difference. Okay, in data lake you were not having this. Okay, with in lake house, this is a newer technology or new framework that lends these warehouse like properties here. Now because of these, right, now what happens because of this? Because you are using a single storage tier. Okay, this is your lake house single storage tier. Okay, you can have multiple compute engines, okay, C1, C2, C3, okay, and it is decoupled, so your compute and the storage is decoupled. Again, I think we discussed this in one of our previous lectures when we spoke about Snowflake as an architecture, right? It is a separate compute and separate storage. The same storage can be attached to different Snowflake virtual warehouses. It is similar. So Lakehouse has a similar kind of a concept where you have a single storage tier and you attach different computes here, okay. This is decoupled, okay. So decoupled storage and compute, and because of this decoupling you can attach multiple compute engines, so it can be Spark, Trino, Presto, different ones, okay. At the same time it is open and cheaper because you are using a storage like a cloud object storage, okay, cloud object storage, which are much cheaper. It is not proprietary, so it is open, you can use anything to access this. Plus, because of this new thing, you can open table format, you can have better BI performance, okay. You can have fine grained access control, asset properties, as well as update and delete, okay. Now this is important one. In data lake, because it uses immutable storage like S3 or even HDFS, okay. If you come from the Hadoop world, you will be aware that you cannot do an update, direct updates on this HDFS, even if you're using Hive, right? Hive is nothing but a metadata layer on top of your HDFS data files. So if you have added some data here, right? If you have a Hive table ABC, and if there is a record 123 comma PQR, if you want to update this 123 to XYZ, this was not directly possible. You cannot run an update query and do this. Okay. Yes, people who are coming from the Hortonworks world, they would be aware that it had some Hive asset properties using ORC files. That was I would say it was not possible for all other ecosystems, or basically those who are using Parquet and all, okay. But yeah, traditionally you could not do an update or delete on an HDFS or a Hive system, or even on a data lake. So these are the basic features that Lakehouse provides you, okay. We are going to discuss how it happens, but for time being, understand that you will get all it's a single storage tier, okay. Single storage tier, that is a data lake or a objects cloud object storage. There is no proprietary storage here, there is like a warehouse, okay. You are not using any proprietary storage, it is all cloud object storage, okay. It supports all data types, structured, unstructured, semi structured, you can store all this data. It would support all your workloads from BI, AI, real time, ETL, right? Interactive querying, ad hoc analysis with a good performance for BI. Okay, even for BI, you will get good performance. You will get data warehouse features like ACID. It will be ACID compliant, so that all your writes, concurrent writes are handled properly. Um, the database won't be in an inconsistent state. Uh, Whatever you do the updates or changes, these are durable and they follow the atomic nature, right? Either complete or nothing. Plus, you get this amazing feature of updating or deleting something. Okay, in a lakehouse, you can update a record or a delete a record. Okay, this is possible. Since the storage is cloud object storage, it will be open and cheaper. The architecture is such that, right, your storage is separate and the compute is separate, so you get a decoupling between the compute and the storage layer. Okay, so that you can use multiple compute engines, and all these things happen because of a technology called open table format, which we are going to discuss in a while. So, okay, so this is at a high level how the architecture would look like. Okay, so this is your cloud object storage. Okay, let me change this color. Okay, this is a cloud object storage like S3, ADLS, GCS, or even if you are into the on-prem world, you are using HDFS, or there is something called as min.io, right? You are using this. Let's stick to S3 or ADLS, GCS, the popular ones. Okay, so you are using something like a cloud object storage, right? In data lake also you are using this. Now there are file formats. So when you write let's say in S3, right? You are writing something in a S3 bucket. You will put it as a file. It would be a CSV file, XML file, or a Parquet file, right? So Parquet, this is the file format. Okay. So three popular formats in the big data world were Parquet, ORC, Avro. Okay. Parquet and ORC were columnar. Avro is more of a row based, right? Nowadays, Parquet has become, most of the data practitioner have started following Parquet. Okay. Um, many projects you would see that Parquet is being used. Yes, of course, ORC is still there, but yeah, in most of the use cases now you'll see Parquet, right? So even in data lake, right, we were doing this. We were writing files into a cloud object storage as Parquet file, and which was our data lake, right? So these two components, file format and the cloud object storage, formed a data lake. Now there is a new thing called as the open table format, okay, which gets added here. Now, what are the open table formats? Okay, and I'm going to talk about this in more details in the one of our lectures. Okay, at a high level, try to understand. Okay, this as it is a way, the open table formats. Okay, it is a way to manage your data files. Okay, let's say in your S3 bucket, there are files A dot Parquet, there is a file B dot Parquet, there is a file C dot Parquet, and D dot Parquet. Now, it may happen if you create a table. So, open table format lends the metadata on top of this. Okay, it gives the metadata, and it will say, okay, which let's say there is a table T1. So, it will say that okay, file A and B forms table T1. There is T2. It will say file C and D forms table T2. So, open table formats are in a way to manage your files, to manage your data files, and it tells which of these data files are part of your which table. Okay, and we are going to talk about this concept in more detail, okay, in one of our lectures. Okay, if you have worked on Hive, if you come from the Hadoop world, you would be familiar with this. Hive was one of the initial open table formats. Okay, Hive did the same thing. It was HDFS. You had this data, okay, file one dot let's say Parquet, two dot Parquet, and then you created Hive table pointing to these files. Okay, there would be folders also, right, in between this, like um, Hive warehouse, right? Hive warehouse slash then you have something like a system, let's say, as a folder or directory. Within that, you have one on two. So you will point your Hive tables to this. Okay, when you created the Hive external table, internal tables, this would be so always like Hive was just a wrapper or a metadata on top of this. It's a similar thing here. Okay, so open table formats is a way to manage your files. It tells you okay which files are part of which tables, and then because of this kind of an architecture it gives you a lot of other features like time travel, support for ACID, support for update and delete. Okay, so three of the most popular open table formats are Delta Lake, Apache Iceberg, and Apache Hudi. These are the ones which are widely used across data projects, or across domains and industries by different customers. Okay, so Delta Lake is something Databricks has been using. They open sourced it later under Linux Foundation. Okay, this is used in most of the Databricks projects and Azure projects. Okay, Apache Iceberg, okay, it's an open source under Apache, right, Foundation. Same with Apache Hudi also. Both of these are part of the ASF, right, Apache Software Foundation, again used across a lot of companies. Iceberg has become very popular now. It is used by a in it is supported by different products like AWS, Snowflake, and Dreamio. Many are there. In fact, Databricks acquired Tabular, right, which again is a company formed by the Iceberg founders. So we'll have to wait and see what happens with Iceberg, right? So even that's going to be an interesting development. Apache Hudi is something which is used in a lot of streaming use cases, right? So one house is one of the companies which again started by the creators of Apache Hudi. So yeah, they have a lot of interesting things happening around. So these are the open table formats, right? We need to consider when we are building a lakehouse. Again, we'll discuss this more in one of the subsequent sessions. As of now, try to understand the architecture, right? It belong what it has is a cloud object storage, a file format, and an open table format. And while this is storage, there is an interesting thing which is a catalog. Okay, while all the storage is there, it there is a lakehouse also has a catalog layer in between. Okay, catalog to manage all these things. So all the metadata, right, it is of all the tables and all, you can see it from here. You can discover all the metadata, discover the tables from here. Okay, this is the catalog layer. Now through catalog, right, compute engines and all access these tables through this catalog layer. Okay, um, so now as we said earlier, right, because there is a separate compute and the storage layer, there are multiple compute engines like Flink, Spark, Presto, Trino, AWS, Amazon, like Amazon Athena, uh, Snowflake, right? Databricks. All these are different. They have their own compute engines which can access any of the storage. So you can access iceberg. If you have created an iceberg file in Flink, you can access it in Spark. If you have created something in Spark, you can access it through Trino. So if you have created something in Glue, AWS Glue, you can update that data using Snowflake, right? All these things are possible now because of this kind of an architecture and this compute engines, right? This interoperability between this, it is supported in Lakehouse, right? Especially through the catalog layer. Okay. You can use any of the compute engine of your choice. So try to understand this, right? This has opened up a lot of new opportunities. See, previously, as we had mentioned, if it's a database or the traditional warehouses, you would have to put the data into the warehouse. Okay, the file would move into the warehouse storage. Okay, and you could access this only through that warehouse compute, okay, in the traditional ones. Now we are saying, okay, you don't have to move this file, you don't have to do this. The file would reside anywhere it is, right? Let's say in the object storage, and you can use any compute engine, right? You don't have to depend on a single compute engine. Okay, so all these things are now possible. So that's an interesting architecture, right? And it is becoming very popular. I have written a book on practical lakehouse architecture. It's available on O'Reilly. There is also a video course, short video course, which I've created, again available on the O'Reilly platform. You can definitely check it out. And yeah, let me know if you have any questions. You can connect with me on LinkedIn. So that's it for this today's lecture. We'll continue this series. We'll talk more about, open table formats and other things, and the overall architecture also. If you have any more suggestions, let me know. If you want to connect with me, I do 1:1 free mentoring on Topmate as well. And if you want to try out any of these in AWS, I can give some $20 free credits as well to try it out. Yeah, that's it, and see you soon. Thank you, guys.